Hello all. Today I will discuss about a very popular hash function MD5. Uh, Actually, it is a very there are lots of complex procedure inside MD5, but we will just keep it very general. So you heard about this MD5 that is message digest, and also we use SHA1, that is secure hash algorithm. Okay. So both of them do the same work, okay, and we are just describe how actually MD5 works. So the process is the sender actually use MD5 to the text, okay, and append message digest or MD, okay, with the plain text. Send it to receiver. Then what receiver do? Receiver compute with MD5, okay, and because when sender send this message, he actually send, let me write this way. So suppose X is the plain text, okay, so what the sender do, he make MD5 X. So he send this plain text and MD5. So this is for integrity, okay, not for confidentiality. If it is for confidentiality, then you shouldn't send this X. Because we are sending X, that means we are not thinking about encryption part. Okay? We are just concerned about integrity. So the receiver received this message. Okay. Again, what he do, he he knows that this is MD5 operation. So he again create a MD5 of X. So how we get this X? Because the sender sent it to him. So this is the X. Then he actually compared this MD5 and this MD5. If both of them are same, that means there is no alternation in X. If there is a 1 bit of alternation in X, so this MD5 and this MD5 will be different. So in that way, the receiver will know that there are some tampering in the input. So in MD5 algorithm, it is mainly 128-bit algorithm. I mean the output is 128-bit. So initially, there will be a different size of message. It can be 100-bit, 200-bit, 5-bit, 10-bit, 16-bit. So what we have to do initially, we have to padded the message to an exact multiple of 512-bit block. So padding means, suppose I have a 100-bit input, but I need to make it multiply of 128. So what I have to do, I have to add 28-bit, so that the input won't change, but the size actually became 128-bit. We use some dummy values or something like that here, so that the inputs are in the exact size. Okay. Also, when we padded this message, we also do some 64-bit addition. Okay. So we are not going in details. Actually, I'm just showing you how this works. And then in second part, we initiate the message digest buffer. Okay. So there are four buffer, each buffer of 32-bit. So 4 into 32 is 128-bit. Okay, and we name it ABCD. There are some round functions, some rounding, and we process the each block of 512 bit, and we finally get the message digest in a buffer. So that was the output. So let me show you some graphical representation. So this is actually how it works. So this message block, this is actually 512 bit. This is 512. This is our message. It actually used in several rounds. So we have 4 rounds. Same thing is going on in each round. There are some computation. There are some, as we have seen in block cipher. There are 10 round, 12 round, and there are some permutation. There are some matrix multiplication. As we have seen, byte substitution is something like that, similar to that. Okay. So initially we initiate the buffer. These are those buffer A, B, C, D. So these are 32-bit buffer. So we have some initializing vector. So in each round, inside each round, we use the message block and use some further computation. We use some constraint, we use some function inside this round, and after that we get the output from round 1 that used as an input of round 2, like this similar way. And finally we use some different module addition modular. We don't know actually this operation. This is actually additional module, not XOR. Okay, this is not XOR, this is additional module. And we finally get this hashed ABCD. Okay, let's see. So now I am showing you the inside of one round. Okay, so we have this initializing vector, we have this 4 block. If each block is 32-bit, and also plain text is used in each block. So each block actually take 128-bit and it generate 128. So these are like this. Okay. So each of them is 32-bit. So we are not going in details. Okay. And each block there is a function. Okay. So FGHI, there are 4 functions which used in each block. So inside this each function there are some logical operations. So we are not going in details. Okay, just giving a general idea how it works. So this FGH, there are some logical operation inside each function. Then we have some constraint value like T1 to 16. So each round is having 16 steps. Okay. So each round have 16 steps, and for each step one constant value is used. Okay. So there are actually 64 values because we have 4 rounds. Every round have 16 steps, so there are actually total 64 steps. So there are some operation in each round where we use this function, and each step there are some constant value, and we use some part of X, I mean the plain text. So we do some computation here, we get ABCD as the output, which is act as an input for the second round. There also we have another function G. So G contains some additional logical operation. We also some constant value and some part of X. So in similar way, uh, after end of the final round or final round, this round 4, we actually do a addition modulo. Okay. So addition modulo we can say like this. Suppose a plus b, if we do like this, a plus b mod c. So what we'll do, we will calculate a mod c, a mod c plus b mod c, then again we do mod c. Okay, so this is not XOR, this is not addition, this is modulo X. So after that we get something in this 128 bit in this message diary. So this value again used in the next round. Okay. There we have the same procedure, same thing, and also we get the message digest that is used for the next round. So after 4 we actually finally get the hash value. Okay, so this is how actually this works. So we are not going in details of inside these functions and how the operations inside it. So MD5 with this 128 bit encryption is have this amount of possible combination. Okay. So if you think about brute force techniques, so it will take a long time, an unrealistic time to crack this the MD5. But MD5 is broken. Now we are using SHA1. MD5 is easy to use. Okay, in database or in some other part you can use MD5 very easily. Okay, it is considered is secure, and because it will take a large computational power, so it is difficult to crack. But you know, when quantum computing is available, then this algorithms are worthless, because this hash function, the cryptographical function, we are focused on which some mathematical problem which are difficult to crack. But because we have some limitation in computational power, that's why there are some limitation. But when this we have some high computational power, then actually these algorithms or these techniques will be broken. Okay, so this is the end of this segment.